Welcome to The Explainer. Today we're taking you from data novices to absolute data sculptors. We're going to unpack exactly how you can turn raw, flat timelines into some serious predictive power. Seriously, if you've ever wondered how these algorithms actually predict tomorrow's sales, or next week's server load, or, next month's inventory needs, you are in exactly the right place. Let's get into it. All right, let's dive right into our master map for today's explainer. What you're looking at lays out 10 essential, and I mean highly effective techniques to really decode and manipulate time-stamped data. These right here, these are the exact mathematical and logical transformations that data scientists use every single day to feed their machine learning models. To make this super digestible, we're breaking this down into a few key areas. First up, the raw data problem, followed by the rearview mirror of past data, the calendar map for important dates, trajectories, trends, and cycles, the multiplier effect of interaction features, and finally, putting together your ultimate feature engineering toolkit. All right, part one, the raw data problem. So look at this stark contrast between raw data on the left and engineered signals on the right. Raw data is just flat, right? It's literally just timestamps and numbers. A machine learning model looking at this doesn't inherently understand human concepts like, say, weekends or momentum. It's just a wall of numbers. Feature engineering is the hero here. It's the process of using math to explicitly carve out those hidden clues and hand them directly to the algorithm on a silver platter. Moving on to part two, the rearview mirror, focusing on past data. So here's the fundamental question for you. How exactly do we teach a machine learning model to remember yesterday? Think about it. Models don't naturally understand time flowing forwards or backward. They just see what's in front of them. If you want a model to know what happened yesterday so it can predict today, well, you have to intentionally engineer that memory for them. And that brings us to technique number one, lag features. By using these, we are explicitly feeding the model historical context. Notice the notation here on the screen. That T-1 represents exactly one time step ago. If you want the model to compare today to the exact same day last week, you just feed it a T-7 lag. You're quite literally copying yesterday's data or last week's data into today's rows so the algorithm can finally see them side by side. Okay, technique two is rolling window statistics. And I like to think of this as our magnifying glass. Daily data is often incredibly noisy. I mean, maybe a Tuesday had weirdly low sales just because of a random thunderstorm. By applying a moving average over, say, a 7-day window, we absorb and smooth out all that daily static to reveal the true underlying weekly trend. You can also use rolling sums to see total volume over a week, or even rolling standard deviations to measure just how volatile the data has been recently. Now this is where it gets fun. We can actually combine those first two ideas for technique 7, which is taking the lags of rolling statistics. Imagine taking that smooth 7-day moving average we just calculated and lagging that specific value. Now you're giving your smooth trends their very own distinct memory. This allows the model to compare current smooth trends against past smooth trends. Let me tell you, it is incredibly powerful for spotting subtle underlying shifts in momentum. All right, let's open up toolkit number 3. The calendar map, focusing on important dates. Technique 3 is all about extracting useful calendar information. Basically, we physically expand one raw date, like November 26th, 2026, into multiple, highly specific time-based indicators. Because let's be real, a computer doesn't naturally know that this random date is a Thursday or that it falls in quarter 4, unless you create dedicated columns telling it exactly that. These discrete features are what allow models to easily group and learn seasonal behaviors. And that brings us right to technique 8, holiday and event flags. Look, if you're trying to predict retail sales, an is holiday flag is literally the difference between a model predicting a normal, quiet Tuesday versus predicting a massive Black Friday spike. By creating these super simple binary yes or no flags, you give the algorithm the exact heads up it needs to adjust for massive expected anomalies. Moving right along to section 4, trajectories, trends, and cycles. Technique 5 introduces trend features. I want you to think of these as our compass. They make sure the model understands the overarching long-term direction of the data, completely independent of all those daily fluctuations we talked about. So creating a simple days since start counter acts as a sort of time index. A cumulative sum keeps a running tally. Basically, these linear features tell the model, hey, regardless of what happened today, we've been steadily growing by roughly this amount over the last 3 years. Next up, Technique 6 shifts our focus to the actual speed of that movement through relative or percentage change. By breaking down the math, subtracting the previous value from the current one and then dividing by the previous, we give the model a concrete way to understand momentum, not just absolute values. A model might not care at all that sales are at exactly 10,000 units, but it will care deeply that sales are suddenly up 12% compared to exactly 1 week ago. Now, this is really cool. Let's look at the mathematics of cyclical time for techniques 4 and 10. Think about the hours in a day. Hour 23 is right next to hour 0, right? But to a linear, flat model, the numbers 23 and 0 look extremely far apart. So by encoding these cyclical features using trigonometric waves, specifically sine and cosine, we preserve the true circular order of time. We're essentially mapping the time onto a clock face. Now the model intuitively understands that December 31st is mathematically right next door to January 1st. Section 5, the multiplier, or interaction features. You know the saying, the whole is greater than the sum of its parts? Well, take Technique 9 as a perfect example of that. Knowing it's a Friday is good. Knowing there's a promotion is also good, but multiplying day of week by promotion creates a brand new, highly predictive interaction signal. It mathematically captures that unique, crazy explosion of sales you only get when a promotion happens to fall specifically on a weekend. It's basically a direct shortcut to help the model understand amplified effects. Finally, Section 6, your feature engineering toolkit. So, looking back at our master map now, it's no longer just a wall of buzzwords, is it? You're actually thinking like a data sculptor now. You know exactly how lag features create memory, how rolling windows smooth out the noise, how those trigonometric functions preserve the cyclical nature of a clock, and really, how all these techniques work together to sculpt raw, lifeless data into deeply predictable patterns. But I want to leave you with this, the ultimate paradox of time series forecasting to chew on as you start building your own models. We've engineered the absolute perfect historical signals, but can past data ever truly predict a completely unprecedented future? That is exactly the challenge that keeps data scientists awake at night. Keep exploring, keep engineering, and we'll see you on the next explainer.